Hey everyone, how are you doing? Hope you are doing great. So, what's up today? Well, the topic for today is records, right? Records. Now, let me first tell you that why indeed such a concept exists and how can this be great, right? Records. So, records in C sharp. No, that doesn't associate itself with any kind of record, okay? I mean, not at least directly. Records doesn't mean that you have a record and just like a database record. We're not talking about those records, okay? So it's not about a database record in true sense. Now, records are a shortcut for a class. Now, how many times you have felt the need of creating small classes? Small classes, okay? Like let's say typically small classes, maybe the class that will contain maybe class person or let's say class employee, okay, that will just contain only a couple of properties, right? Maybe you'd like to have well, just about the employee ID. Maybe we like to have employee ID. So what we write is we write properties, right? We just straight away write properties. Maybe we can write fields as well. That depends, but mostly we write properties like int employee ID and then get and set, right? Don't worry, I'll very soon get you into Visual Studio. Just want to discuss the basics first, okay? So many times you have felt the necessity of having small classes. Now they are typically known as domain classes or DTOs as well, used for data transfer purpose. So you just want to transfer data. For example, let me complete this. Uh, we have got employee name and we get and set, and we have got string department, department, sorry my spelling, department, get and set again. All right, and maybe one more, double salary, get and set. Okay, simple enough, right? So we have been using these kind of classes every time in our project. We call them model classes. We can call them model, we can call them DTOs, we can call them as domain classes. In one word, they are small classes. Why am I saying small classes? Because they don't really have methods, they really don't have any bigger structure. They usually don't inherit from some another class, right? I'm saying not usually, they can. So the typical thing is that they are small and they're used extensively in a project for typically holding data between two different program units. Maybe that you are transferring some data from your client to an API, right? So you just want to have little small class that will get your data and just happily transfer data in and out around, right? So for these purposes, can we do it even smaller? Most of the time, for these kind of classes, we also anticipate certain behaviors. Let's now get into Visual Studio and show you what I all mean. Let me copy this. Let me create a new Visual Studio project, a console application, and I'm creating in .NET Core. Okay, that's my folder. You can choose your own folder. I create under C: work self, and then records example, right? Example. And I like to create this console application project under .NET 9. So very soon .NET 10 is going to be out, maybe this October. By the time you are looking at this video, maybe already .NET 10 is in production. Who knows, .NET 12, 13. But these concepts are there for long. The records were introduced long before. So records are not just a new concept. Records were introduced, I believe, in .NET 9 or so. Yeah, and sorry, in C# 9 or so. So records were introduced long time before. You can just Google. I just forgot. I can Google now, but let's leave that. Okay. So yeah, it was introduced in C# 9. Right, I'm absolutely right. C#9. So now let me click next and create my application. All right. Now let me paste this directly here. So this is a typical small class which will be useful to just store some information that does not do any validation. Yeah, one more important thing about small classes, and I call it small class, okay? You can call it anything. Typically, we can call it DTO. DTO. That's the technical name to it. DTO stands for data transfer objects. Okay. All right. So now let's try to create an object of this employee class. Employee equals to new employee, and then typically we'd like to create an object. Now, object can be created either through a constructor, which we really like to, right? Because we know that we have to be initializing all of these fields. One more important thing is that for small classes, we do initialize all of the fields because that's the thing we have. I mean, we have just 3 to 4 fields, right? Any classes which has more than, let's say, 7 or 8 fields or even large number of fields, we can't consider that a small class anyhow, right? So for small classes having 2 to 3 fields, maybe maximum 5 fields, we can consider them small, right? Now the question is that, do I need a constructor? You can really create a constructor that will still keep it a small class, right? So that will still keep it as a small class, okay? So but right now I don't have a constructor, so I have to be initializing through properties. Let me initialize them to the properties using property initializer. So I am using employee ID. I'm sorry, I didn't make it public, so I need to be making them public, otherwise we can't access them. Okay, how did I do it together? I just clicked somewhere, and then after clicking I will be pressing the alt key in my keyboard, and then I can draw a long cursor. Okay, and then I can type anything that automatically types. Okay, all right, you can try that at home. And to get away with that, I can click outside, and that long cursor vanishes. So employee equals to new employee, and then this employee ID. Let me store something, maybe 10. Maybe the employee name is anything, maybe John. All right. Let the department he's working in is IT, and the salary that he draws is some 50,000. All right, let that be. All right, so now we have an employee. We have one employee. Great. Now let's say we obtain another employee from some another source. I mean, yeah, from another source. Now I don't have any another source. I just am working inside this main. So let me get a copy of that. Okay. So this is E and this is F. So now that we have got 2 employees, E and F, and what do you think? Now I'm asking a question, putting a question in front of you. Let me write this if statement. If E, which is having the same data as that of F, now if E is same as F, then it will print data are same. And if it is not, else I'm still not into records. I'll come to that topic. I mean, I'm just trying to create a backdrop, that will help you to understand how the things really work and why records are so important. So let me console a right line. I'll say data are not the same, right? And then I would like to stop it by using a console.read key. All right. So, question for you. Answer me what you really see at this time. Will you see data are not same? Data are not same? Or will you see data are same? We have got absolutely the same data for both of them. Both the employee E and F has the same data. So what do you think? What answer should you get? You can just pause for a few seconds. Hope you had an answer now. Well, let's check what is your answer and how exactly is the answer. data are not same. All right, data are not the same. Now, if you are typically wondering, hey, what happened? I've got the same data, then I should tell you that you should be revisiting some of the old contents. By the way, those who don't know I am basically a one-to-one .NET instructor. I'm doing that for the past 20 years and plus, and I'm into .NET for the past 25 years though. And you or anyone would like to have a one-to-one training with me can definitely give me a tinkle. The description of what has been given in the section below. All right. So now, if you don't understand this, that means you have some fundamental difficulty in understanding values and the references. Okay. So these two are not actually values, even though they have the same data inside, absolutely the same data inside, but they are two different reference types. Now, two reference type cannot compare themselves like that. All right. Two reference types cannot compare themselves. Why? Because internally, these two reference types works as a pointer. This E will be pointing to an object which is definitely in the same, not in the same location as that of this object. So these two objects, these are the objects. Please understand, these are the objects, whereas E and F are not the object. That's a typically wrong conception people have, is that they think E and F are objects. E and F are not objects. E and F are references of objects. They're pointers. For somebody who has gone through C++, they know what pointers mean. So pointer to a real memory unit. All right. So that was just a kind of revision for those who already know. So now ENF being references, you cannot compare references for its values. You can't do that. If you really want to do, you have to be comparing against all of them. Like let's say if E dot employee ID double equals to F dot employee ID. That is, you have to be comparing against all of them. I know it's boring, but that's how it works. So E dot employee name double equals to E dot employee name, and if E dot employee department equals to F dot department, and then maybe E dot salary double equals to F dot salary. So you can really see there are a lot of comparisons, and this is inevitable. This is what you need to do. You have to be comparing member by member. So we are comparing whether E, the object pointed by this is employee ID, is same as the object pointed by this F. Then again, the object pointed by this is employee name is same as that of employee name, right? So you have to be comparing all the member by members to ultimately reach up to the conclusion that data inside them are same. Not definitely the answer will be data are same, right? So if you have got so far, if you are with me so far, kindly give this video a thumbs up. Thank you for your patience. All right. So now data are not same, you know it. So you have already got this point, right? Okay. Now there is something, as I was telling you, is records. Let's see how the record concept makes the thing simple enough. Okay. So what are records? As I've told you, records are small. Records are small classes. Now they are of course not written in this way. They are written perfectly in a concise, compact way. Let me show you how. Now, I like to comment this because I can't keep this record and class at the same time with the same name, of course. I can create a separate record, but I like to keep the same name. So how do I create a record? Just start with record. Just like you write class, you just write record. And then employee, create. And then this is amazing. You don't have to be giving those properties member by member. All you can do is that you can create a constructor like situation. So I like to copy these things and like to keep them side by side. All right, they even don't have to write public. So the string name, as if you are creating a class with a constructor. Look at this. It seems like we are creating a one-line class with a constructor. right? And that's it. We will end it by hitting a semicolon. We are done. Think about it. We are just done. So a record is a one-line class. All right, a record is a one-line class. We start by defining record. It can also be public, just like classes can be public. If you want to be exposing your class or type outside the assembly, you need to make it public. Probably you would already know that. So record employee, and then you have all the members inside, like employee ID, name, department, salary. All right. So in this way, you have successfully created a simple one line data transfer object class. Okay, I should say record. Now it's no more a class, it's a record. But yeah, one thing, all the records internally are classes. Yes, this is true. Now, what kind of record is this? The records can be classified into two ways, two categories: positional record and regular records. This is an example of positional record. We have regular records too. I'll just come to that very soon. And regular records looks much the same as that of a class. It has got higher facilities, but as I'm telling you that, like for the higher facilities, we can even opt for the classes, because classes are the ultimate one. All right, you can use class for doing anything. You really don't need record at all to work in your project. Just that it makes life easier. It like makes your life simple. All right, that's why we come to records. So it is not, there is nothing that can't be do using classes which can be do using records. Ultimately, we have to be writing more code to make it happen. But in records, the records are geared towards doing the same thing using a simple syntax, and even without writing any boilerplate code. All right, so you avoid writing many boilerplate code. So let me show you how. So this is a record syntax, is a positional record syntax rather. And now, first of all, in positional record syntax, we can't use the property initializer. All right, so they are bleeding. They're kind of bleeding. You can't use the property syntax. All right, so how can I do that then? Okay. So one thing that you immediately understood, that in positional records you can't use property syntax, but you can of course use this is the constructor kind of syntax. Let me recreate my E and say equals to new employee, and as I start the parenthesis, I see all my values, so I can now transfer them. So let me transfer my values. John just works like a constructor, isn't it? Such a great thing. IT salary is, all right, that's John. I'll hit Control D. I'll make it to F. So now E and F are two records. So if I hover the mouse cursor on E, it just says employee. If I hover the mouse cursor on employee, it says a record. So employee is a record. Now, with the records, I don't have to do such a kind of bulky boilerplate kind of comparison. So we are back again. You can see the beautiful stuff with the records. So if I write E double equals to F, it just works, man. Such a cool thing, isn't it? If I run it, I don't have to be writing, comparing member by member. It just works. Data are same. So what conclusion you have right now? A record is internally a reference type, but it compares data like a value type. So records combine the beauty of both the worlds. So records are internally reference type. There is no doubt in that. Let me tell you. Records are not value types. If somebody is asking you in an interview whether records are value type or not, records are really not value types. Record is a reference type, okay, just like classes, but it compares instances by value rather than by reference, and it's really an ideal for scenarios like DTOs, for data transfer objects, for configuration, for configuring models, or any read-only data structure. Yeah, one more interesting thing is that records are read-only. All right, so records are read-only. That's another important aspect of records. All right, so now that we compare, and you can really see the things are really working great, right? Now, why am I saying records and read only? Let me try something and try it whether it works or it fails. It started failing immediately. You can see once you can definitely read the values. There is no doubt. If you want to read, you can read. Let's say e dot employee name. You can read that. There is no error in that. It's absolutely possible. You can read the employee name out of this e, and it really lets you to read that. But what if you try to set it? You can't. You can't set it at all, right? Because it will tell you that is an init only property. All right, so you cannot save it. It's a read only. So records are read only. Please bear in mind that once you create records, your sole purpose is to welcome that data and let it get seated into this chair, into this box, and just transfer that. It's kind of boxing the data, packing it, and parceling it, right? So like packing and parceling. You don't really do any kind of like manipulation, like changing or anything, right? So understand these little requirements. So if that is your requirement, just getting the data, packing up, and calling an API. Okay, or let the API has got the data packed up and transferred back the data to the client. For this kind of packing data and sending data, this is indispensable. This is such a great thing. Records, absolutely. All right, so by now you got more test of records. May you have something more? Why not? Let me show you. So, all right, so now one interesting thing of records is that you can create a copy of an existing object with not much effort. Like let's say if I create an employee, G equals to E, employee G equals to E. Now, if I write employee G equals to E, that really copies everything that I have in employee E into G, right? This copies member by member. But then we like to say with, and then you write the salary, maybe that he has a higher salary, maybe 85,000. So try to understand what I mean to say is that. So that means the G is the new employee who is same as John, but with a different salary. Maybe I like to change the ID as well. Maybe the employee ID equals to 11. So that means there are two Johns, one with an ID 10 and one with an ID 11. So they both work in IT department and they draw different salaries based on their experiences, right? So this is G. So how easy it is to copy an employee, to copy one instance into another instance. Now this kind of feature are really not available in classes. So you need to be understanding that something of this nature is not really available in classes. So if you really have to be doing in classes, you have to be writing a copy constructor, doing a member by member copy, a lot of things. It's absolutely worthless to do all those things, for such a small thing, right? But for bigger members, for larger things, you need to do it. I've already had some video in my YouTube. You can go check that, the how to be copying like member by member, how to be using copying mechanism, right? So how to be using auto mapper. You can go check that video too. So therefore, big objects, right? Big objects. But for usual small objects intended to just transfer data in and around, we use records, and you will find a lot of records being used in your projects, right? So this is one such thing, and another beautiful thing which is already inherently there within records is the feature of deconstruction. Yeah, what is deconstruction? I just recently posted a video, uh, probably my last video. Yeah, you can go have a look. So deconstruction is a feature in which an object can immediately deconstruct itself or destructure itself, like React. For those who have done React, they know there is a destructuring feature, the same as this, okay? JavaScript to have a destructuring feature, right? And the same feature is also available in Python, right? So, every languages are copying from each other. Now, initially, .NET never had this feature, honestly, but with advent of time, I can see that languages are copying stuff from each other. All the good things are being copied, which is absolutely great. So in C sharp, there's a destructuring or deconstructing. C sharp calls it deconstructing feature, which can let an object to deconstruct into smaller variables. How come? Let me show you. I can write a var, and I know I have got four variables: ID, name, and then the department and the salary. So let me create four variables: ID, name, department, salary. Okay, we can keep this variable small, and then look at this. I'll just write G and deconstructed. Great, isn't it? So that means these G's, all the member will automatically come and sit into these variables. So that means G has an employee ID, which will come and sit into employee ID, the ID part. G has a name, which will come and sit into the name part. G has a department, will come and sit in the DPT part. G has a salary, which will come and sit in the salary part. Isn't this brilliant? This deconstruction feature. Deconstruction. Deconstruction in C sharp. Okay. Now this feature can also be used for classes. Okay. But for that you have to write a deconstruct function. But in records you don't have to. I mean, not in all records, in the positional records you don't have to. So deconstruction is automatically gifted. This is a brilliant piece. Now if I run it, you will see, I can show you that it will be showing up all your information. So ID, name, and DPT, and salary. I write it down that after deconstruction. Okay. After deconstruction, this is the result. Let me show you. Deconstruction, you have the ID as 11, John, IT, and 85,000, right? So I hope that you have gone, if you have come so far, which is absolutely fine. This is an easy concept, easy topic. People use them so much in projects, records, right? Now, what if we really don't want to be initializing all the properties? Let's say you have a class which is now getting little bigger. Now you don't want to switch to class. Just okay. You don't want to switch to class. You still want to enjoy the benefits of records. That is comparing like this, maybe with using the with statement. This is a gem of its kind, using this with. This is so easy and handy. You copy everything and then replace whatever you don't want, right? So if you still want to stick to using these features and you don't mind the object to be read only, all right, if you don't want the object to be read only, which is just a very prime requirement for records, that records once created, they are read only. All right. So if these are your wish, and also you want to grow beyond just 4 to 5 fields, and you don't want to initialize all the parameters, here you are mandated to initialize all of them. You can't leave anything like that. So you are mandated to initialize all of them. So if you don't want yourself to be initializing all of them and still would like to use the benefit of a class, then benefit of a record, then probably you'd like to have a record working like this, isn't it? Here you might not, let's say you don't want to be referring to the department, or you don't know the salary as of now. Let's say an employee has joined recently, his salary has not been told, maybe will be told after a while. So he has been given an ID, name, and department. However, he doesn't know his salary, or we don't know his salary. So you want to not to be initializing the salary for now. Maybe that we know the employee, we don't know the department and the salary as of now. So he has joined a company, not knowing exactly in which department he'll be put and with what salary, or maybe that we don't know. So for these situations, we can't keep it empty. Like we can't just have like insufficient data. It will start bleeding immediately, right? It will say you need to be providing all the 4 details. So for these cases to be working, you need to be creating something known as Tell me, tell me. Regular records. Yeah, it's a regular pack. Okay, regular record. Great. So how exactly regular records are created? Now, for creating regular records, it is almost same as that of a class. So I'll copy this again. I'll copy this, and this time I'll comment this. Okay. Now I'm commenting. I'm not changing this to regular record. A regular record can do everything that positional record can. So it's an upgrade. So now that you have a regular record, the very moment you write it, you will find certain features are not working, right? So that means regular record will need more boilerplate code to make them happen, right? So usually they don't work out. So how can you make use of regular records? So first of all, to make sure that the constructor kind of syntax still works, you need to be creating a constructor. For that, I can just hit, I can just right click on it. I can go quick actions and refactoring, and then I can just want to create a constructor, right? So that created a constructor. I want my constructor to be created down. Okay. So that's a constructor created taking ID, name, department, and salary, and I have saved them into my fields. So as of immediately you see the error is gone, right? So you need to be providing the constructor, but you don't see, the but you still see that the construction is not working. To to make sure that the construction works, you have to be writing a deconstruction syntax. I already have made a video on deconstruction. You can go ahead and look at that. But let me just right now tell you deconstruction is a reverse process of construction where you take the internal values of a class or a record and post it back to the caller. That is, you take the internal values and you post it, throw it back to the caller. Let me show you how it works. Well, you just go ahead and write a public void deconstruct. You have to be writing it exactly as it spells, deconstruct, right? And then, yes, you need to be having all of them, but now this time they are not inputs, they're outputs. Okay, outputs means they are going to be setting those var inside parentheses, some variable comma some variable comma some variable some variable. Okay, so they will represent those var stuff out there. Okay, these stuff. So we have to be decorating them with outs. They're outs parameter now. Out, 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 and out, right? So they are all out parameters. Now next what we do? Next what we should do? Tell me. If it is just opposite of constructor, so deconstruct is opposite of constructor. Construct. Construction means you have your data and you want to be construct your members member by member. Okay, you want to be constructing your member data, and deconstruction is just opposite. So that is, you already have the data within your member, you want to push those data into those outputs. Let me show you how it is done. I can just write employee ID, which is a variable, the small employee ID, equals to employee ID, which is my member variable. Now I always prefer to write members as this dot. I always would like to prefer to even write them as this dot. In React, in Angular, which uses TypeScript, and in Python, they really want to write, they want to specify their objects. Some uses this, some uses self. Okay, so that means in here you should, C# was not initially meant to be writing this, but I prefer this. It clearly distinguishes from the normal variables from member variables. So bear in mind, whenever you have member variable, it is a good practice to write the current instance dot id. If you don't understand what this is, well, this is something fundamental to object orientedness. You can go check my other videos. All right, or you can come to me for one-to-one classes as well. I'm more than happy to assist you. So now this emp equals to this dot employee id and then emp name, equals to this dot emp's name. Okay, this salary or this department out parameter equals to this dot department, and the salary equals to this dot salary, right? We have already created the deconstruct function now. Now if you go ahead and see, this really is not bleeding anymore. So what does that mean? That means that you now have created a record which is pretty much almost same as a class now. This is a bigger definition now. It's a bigger cousin of positional record. Okay, regular records are really big because you want to get more flexibility while using. If you want to get more flexibility, you can switch from positional record to regular record any moment of time, right? Any moment of time. So one thing I'd like to still show you. Okay, first of all, let me run and show that these things work as before. Absolutely, that worked as before. Now, can I still write employee name equals to something? I can. So this is one interesting thing about regular record is you can still save them, right? Let me actually have this employee ID as, okay, whatever, maybe my name, okay, Sudipto. All right, and let us try to print this employee. One very interesting thing about records are that you can directly print a record object, which is never a case with an object in general. So I'm trying to print this employee, which is now Sudipto, that is 10 Sudipto IT and drawing 50,000. Okay, so of course data won't be same, it will say not the same. So now with the regular records, it is a possibility to have your data changed. So regular records is almost like a class. It's very much like a class, yet it has retented it has already got all the important features of the records. So what's the trade-off? If you really want to go small, do it quick, just create the positional record. If you don't want to be changing your data more particularly, go for positional record. And in future, if you think that, okay, maybe that we'd like to change the data, why not? You can go for a regular record. Okay, but let's say you don't want to change the data, you still want to you want to retain that simple property of a record, which is actually much more respected. Usually records should not let their properties to be changed. Okay, in that case you can change all of those sets into init. Yeah, init. You can, instead of get, you can change them to well, yeah, init should definitely work. Inits, you can change them to init. Why is it bleeding? Can I change them to init? Am I doing something wrong? Init. Now, when you change, oh, I have right int. My gosh, I'm spelling it init and typing int, and Visual Studio is also also automatically sensing int. This is so funny, man. Yeah, init. If I write init, so I wanted to keep on typing init because I know it works. So if I write init, then you can't save it. And this is not just a feature with record. You can use this feature for classes as well. If you don't want it to be, if you don't want to be changed, init means they are basically immutable types. So once you have changed, once you have done the initial setup, you can't change anything further. Okay, so they are auto init type. With the positional records, they're definitely auto init types. With the regular records, you can choose both the worlds. So regular records is the classes also having the benefits, all the benefits as that of record. So now it's up to you what you choose and what you don't choose. Okay, so hopefully that was extremely clear. And one thing you might have seen that for records you can directly print the instance. This was never ever a possibility in classes. Look at this. It printed so beautifully, right? It printed so beautifully. You can print directly. You don't have to print member by member just to check the data inside. Like we have printed member by member. Here we did that because we had a deconstruction. Okay. However, we could have printed G directly. G. Okay. So these kind of features are so great. They're gem of its kind. I'll tell you why not in your next project give records a try. This is such a beautiful thing. It really, does those reconstruction. It can compare data. You don't have to be going for those fancy, you know, those copy constructor to copy data from one another. Maybe you have to be doing the comparison for those cloning and comparisons. Okay, you don't have to be going through all those things, all those boilerplate code. But with simple stuff, I'll still tell you that positional records are brilliant. Instead of going for a regular record, most of the IT like projects that I've seen, they use positional record because they are simple, they are small, they support deconstruction feature automatically to deconstruct the object into output variables. However, if you want to make it big, if you want to have both, so what I personally feel is that the regular records are brilliant for the case when for the case when you have to be associating the data not only using the object initializer like that, but also using the constructors. Okay, I didn't show you one thing. It's my bad. I can actually I didn't show you, so let me uncomment this and show you that this absolutely works. So yeah, this is native. This is native to, I'm sorry, this is native to regular records. I can definitely do that all the time, right? So regular record will really support that. Why is it reading? No argument. Oh, now there is a big problem. You see, there is a big problem. It says that now that you have to be having the default construction as well. So now I have to be having the default constructor the same way. See, tap tap. Because if I don't have the default constructor, it will not be let to work this way. Okay. So that means it has become almost like a class, right? So but if you never wanted to write this constructor, if you never wanted to write this constructor, then we are fine. Just write this much, it turns to a regular record. In addition to that, please have a deconstruct. So the final takeaway, to have a regular record, have just your properties, define the properties, define the deconstructor, you are done with regular record. Regular record usually are not initialized using constructor like syntax. You'll not see in the internet. You'll not find it. It is what I have personally done, researched, and found that I have not even seen in ChatGPT or anywhere else. Okay, so what I can tell you is that as a rule of thumb, you should be using positional record for most of the time, for most of the purposes. However, if you want to have a manual deconstruct method, now what this manual deconstruct method will have is that you can now initialize part of it. That is, you may not initialize all of them, just a part of it. All right, you don't have to be initializing all of them, just a part of it. If you want to enjoy this benefit, please go for the regular record. If you want to be initializing all of them, please go for the positional records. Right, I hope that has made some sense. Now if I really run it, that see, as I printed this E, so there is no such department field initialized. So you can partly initialize record, then you should be going for the regular record. If you think that your record aren't really big, is not really big, just having 3 to 4 fields, and you want to be initializing all of them, please go for the positional record, right? But records are great. I hope to find you using records in your next project. That was it for now. There are more benefits of records. I may come up with that some other point of time. So that was it. Hopefully, it was a great session. Thank you so much for being here. Bye bye. Take care.